I think, is there any problems about the application scenarios? Because this part is very important for the energy storage system. It determines the how does the energy storage system work, and also it will affect the system operation and control strategy, and also it will affect the system design to give the customers the best suitable design for their demand. So is there anyone some questions about the application scenarios? Is it clear for my introduction?
All is clear? No questions? No? Okay, I think we can continue.
Okay. And based on the functions we have, we can achieve a different application. As you can see, the first is time shifting. We know time shifting is you make benefits from the difference of electricity price. We have a Planck curve function. You can preset the charge and discharge time. For example, you can set the charge and discharge time as tomorrow's electricity price level. As we know, from the evening to morning, the electricity price is normally a low level. We call it valley time of the price. And then we can, because the Planck curve function can set 8 different periods of charge and discharge time, and the weekday and weekend can be separately set. And from evening, like from 0 a.m. to 8:30 a.m., the price is low. Then we can charge the battery at a certain power at a low price level. And then from 8 a.m. to 10 a.m., 10:30 a.m., when we start to operation and production for the factories, we can let the energy storage system to discharge to provide energy for the load. And we can and so on. This time slot set is the same. And we also can enable the zero export function because, as I said before, there is some requirement of some limitation. The renewable energy system can inject a certain power to the grid. So in order to limit the power inject to the grid, we have zero export function. There is a smart meter to detect the power flow direction. If the current direction is from the energy storage system to the grid, that means there is a power flow from the energy storage system to the grid. Then we can limit the energy storage system discharge power until the energy storage power equals to the load power. And we also need the local controller to communicate with the smart meter to read the operation data. And for this time shifting, the last is about when we know the electricity price is fixed. If the electricity price is dynamic, it's usually upon market, so it's dynamic. It's change every day. So in this situation, we need a third party like an energy management system to manage the whole energy storage system to discharge and charge. Because for our energy storage system, it cannot directly know the information of electricity price. And then for this situation, the energy management system, the EMS, can get the information from the website of the local government, and then it can send the order to the energy storage system. It's the active power order or reactive power order, and because we have remote control function, and the EMS can send a relevant power according to the electricity price. For example, when the price is at high level, the EMS send a discharge order to the energy storage system. Then the energy storage system can discharge to provide energy for the load. And when the electricity price is low, the EMS can send charge order to the energy storage system to storage the energy from the grid at a low price level. So in this situation, we can make benefits from the difference of electricity price. And this is peak shaving. As you can see, this is a curve is the same about the peak shaving because there is a maximum power attracted by the customers. So if the load level exceeds this maximum power, this part for this peak time part, the electricity price will be higher than the normal price. So in order to reduce the electricity cost, we have an energy storage system. We have a demand control. It's related to this application because we can set a demand control threshold. For this point, we can set like 100 kilowatt. If the load level is greater than 100 kilowatt, then it cannot get much power from the grid because the extra power will be provided by the energy storage system. And we also can, because we also have Planck function, we can set all day charge the battery to storage the energy in case of the next time we need to discharge to provide the energy. And I think this is very popular for this existing PV system because for some existing PV system, there is a need of we need to add an energy storage system to balance the solar energy. So for in this application, if the PV energy is greater than the load, then the extra energy will be injected to the grid. Or if there is a limitation of the grid to not inject the energy to the grid, then we will limit the inverter power. So the extra solar energy will be wasted. So in this situation, the energy storage system can use the extra PV energy to charge the battery. So we can maximize renewable energy utilization rate. As you can see for this curve, the blue one is the load curve, and the yellow one is the PV curve. So in this part, the PV curve is greater than the load level. The energy can be charged to the battery to storage the energy. And when the PV is not enough to provide energy for the load, in this part, the energy storage system can discharge to provide energy for the load. So it can maximize utilization rate. And also we have a zero export function because in this situation, if the PV energy is greater than the load, the extra energy, some part of extra energy will be charged the battery. But if there is still PV energy, there is still more PV energy, then the PV energy still can be injected to the grid. But as I know, for most of inverter in the market, the inverter has its own zero export function. So combined with the inverter zero export function and the energy storage system zero export function, we can realize the whole system zero export function. And also this situation is we have the EMS. We have EMS to manage the whole PV system and energy storage system. So in this situation, our energy storage system only provide like a communication protocol to EMS, and the EMS as an energy management system will monitor and control and manage the whole system including the PV system, like the energy storage system, and also there may be some other parts like wind power and so on. And the solar energy and store are controlled by the EMS. The EMS just sends the power order to inverter or to the energy storage system. So in this situation, it's relatively easier for the EMS to manage the whole things. And this is backup power, because we know for commercial and industrial application, for some load, it need a continuous power supply. So if the grid breaks down, if the grid breaks down, then there is no power supply. So combined with our energy storage system and the switching cabinet, we can realize when grid breaks down, the energy storage system can control the switch to close, to change the status from on-grid status to off-grid status, and can support to provide continuous power supply for the load. And if the grid becomes normal, and we can detect the voltage and frequency of the grid, and then the energy storage system can control the switch to close back to the on-grid situation. So then this situation, the grid can still provide power for the load. And is there some questions about the applications about the Solution 1 e-store product?
Any questions on that? Should I pass the microphone to anyone? Or all is clear? Or nothing is clear? Seems that either one or another, they are smiling, so I think they almost follow you.
Okay.
Continue, please.
Great. And the Solution 2 is quite different from the integrated energy storage system solution. As you can see, it's an integrated solution that all the devices are integrated in a whole container, and the container size is different. Depends on the customer's demand, depends on the capacity, depends on the battery capacity, depends on the power conversion system capacity. We have a standard like 10 feet and 20 feet, and also we have 40 feet from the minimum 100 kilowatt to 200 kilowatt hours energy storage system to maximum several megawatt levels, meg levels solution. So this solution compared with the cabinet, it's more flexible to do the configuration work, because you can say in this whole container, it is including the solar inverter, the PV system, and also the energy storage system, the converter, PCS, and the lithium-ion battery system. And also, if there is a need of off-grid application, we also can add the on-off-grid switching cabinet to realize status switching, and also the smart meter to detect the power, and the energy management system to control and manage the whole devices. And also consider to the safe feature. We have a fire suppression system in the cabinet, and also the cooling system for the battery. It's a full range and cost-effective. It's a turnkey solution. So all the devices will be installed in the factory, and it's easy for installation and maintenance. And as you can see, it's more flexible for system design. It's because you can say if you already have a PV system, then we can just only provide the energy storage system. And if you want solar power, we also can provide a relevant C&I inverter, like string inverter from SPI 100 kilowatt to 125 kilowatt, and you can flexible change the units of the PV power. And also for the PCS, we have 100 kilowatt, 250 kilowatt, and 500 kilowatt. And also for the battery system, it's the most flexible, because we know the battery system in the energy storage system take a greater part in this system. So 1 kilowatt, so 1 kilowatt capacity, it means need more money. So if you don't want more battery system, then we can adjust the battery capacity as different application scenario. And we also need to also pay attention to the output voltage, because for this solution, it's I think for most C&I application, it's 400 watts, and for the frequency, it's 50 hertz. And also we need to consider the protection grid, its epi grid, and the installation space. And you can see for this distributed PV and energy storage system, it's a turnkey solution that we can give customized solution as different customers demand, have different capacity demand. We can give customer design like the energy management system to realize to configure the operation control strategy and the capacity configuration. And also we have a customized factory to manufacture different customized solution. And also we have customized factory acceptance test to make sure our product has a high quality and has a severe testing to guarantee the quality. And also we can provide a bit support and like tender support. And also for large scale energy storage system, more than several megawatts, we can also do the design and simulation of energy storage system work. And also for testing commissioning, we will do this work before delivery. And when this product is delivered on site, we will arrange our technical engineer go to on site to give on site support to let the commissioning work successfully finished. And next are some typical cases about the energy storage system. As you can see, this 500 kilowatt and 1 megawatt hours energy storage system in Croatia, its application is about low time shifting to make benefits from the difference of electricity price. And it is equipped with on-off switch cabinet. So it can also be emergency power to provide energy for the load when the grid breaks down. So for this energy storage system, it can reduce the cost of electricity. And also for this 100 kilowatt, 400 kilowatt hours ESS in France, its application is for load shifting to provide energy for when the load level is high. And also for this demo project in Italy, it's our 100 kilowatt power converter system to realize to combine with existing PV system, to realize like peak shaving, PV self-consumption, And also there is equipped with on-off switch cabinet to serve as emergency power. And for this, this is a whole integrated PV and energy storage system in Poland. It's also to realize peak shaving. Also can be seen as a backup power to provide continuous energy. And also for the energy storage system, it's also important to can be combined with other parts like the EV charger. And we also have successful cases like this in Poland, combined with a PV system, energy storage system, and EV charger in Poland to realize the maximum utilization of renewable energy and to reduce the electricity cost and make benefits. And also for this energy storage system, PV and ESS in Sweden. So this following tips about some important questions that we need to consider for the whole energy storage system design. As you can see, the first is the application. We must need to attach great importance to application because, as I said before, application involves what we want this energy storage system to realize, and which is a function of the yes you want to realize. And like you must know clearly about some typical applications like what is peak shaving, what is time shifting, and so on. And the second is the load. I think for the load, it's very complex because you need to know what's the electricity load in your whole system, and you need to divide them to different type, which is critical and which is a normal load. Because we know critical load needs to get power supply continuously. But for the normal load or some secondary load, we can abandon when the grid breaks down and when we have not enough energy. And also we need to know the load power, the peak and value time of the load. When is the peak time and when is the value time, and the peak hour and the value hour, because this it will determines the capacity of the energy storage system, and the capacity also involves the budget, the cost of the energy storage system. And also we need to know what are these components in this whole system. Is there other devices in this whole system? Is there a PV system? Is there EV charger, or is there wind power or other renewable energy? So it will also affect the capacity of the energy storage system. And also for the budget, I think it's in the market. I think when we talk about energy storage system, some customers will sometimes just say, "Oh, give me a quotation and give me the cost of the energy storage system," because I think the capacity will directly determine the budget. So we also need to know what's the customer's budget constraint, and we can give the relevant energy storage system. And for the installation, because for the integrated energy storage system, the e-store cabinet, and also the containerized energy storage system solution, it has a different footprint, because for the e-store product, it's a high integrated solution. Its footprint is only 1.3 square meters, 1 unit. But for containerized energy storage system solution, it will occupy a large space. So we need to consider the enough installation place, then we can select the correct and suitable solution. And if we have a multi-units parallel operation, we also need to consider the space, the topology of the whole system, and also the location place. And the next is the environment, because I think for the energy storage system, the environment will affect the cycle life, will determine the life of the battery system. We need to let the energy storage system operate at the most suitable environment, so we can extend the battery life as much as longer. So like the temperature, the lowest and the highest temperature, and the altitude, because when the altitude exceeds a certain value, the converter will have a degradation of the power. And also for the battery system, it's also the same situation. And also the protection grade and the anti-corrosion level. If we know if the energy storage system is installed near the sea, which the environment is high corrosion, high temperature, so we need a higher anti-corrosion level. So we can change a higher level like C5, like 3.6, and so on. We can give the customers the best and suitable solution. So I think that's all of my introduction. If you have any questions, you can feel free to ask me. No matter what questions, you can just directly ask.
We will stick now just the questions about the Kehua products, no matter what questions. So
any question is okay.
Okay. So any questions from you, from the audience, about batteries or solar systems or anything? Anyone? From the last? Yes, you had a question, and I saw the hand was rising. No, not there. So anybody? No questions? Oh, you are so tired in this evening part, yeah?